Okay, so we're graphing reciprocal functions. This is the original function they've given us, right? So then the reciprocal function, called like this, will be 1 over 3x plus 2, right? Reciprocal function, the first one, sorry, the original function is just a linear function, a y-intercept of 2 and a positive slope of 3 over 2. So this being 2, something that would look like this, okay? This function, first of all, we know can't exist if 0 is on the bottom of this function because we can't divide a number by 0. So that means we're going to have a vertical asymptote of something. So we take the bottom of this function and we set it equal to 0. So we'll get 3x plus 2 equals 0. And we solve for at what point our vertical asymptote will exist. We bring 2 over, we get 3x is equal to negative 2. And we divide by 3, negative 2 over 3. So we have a vertical asymptote at negative 2 over 3. So let's bring a graph out. Scale of 1, hopefully that's enough. Okay. So here's our graph. We'll zoom out a little. Let's make sense of this. So first of all, we have a vertical asymptote at negative 3 over 2, or 2 over 3. So that's like 0.6. So I guess that's somewhere like this, you could say. Okay, there's our horizontal asymptote for the reciprocal function. The original function has a y-intercept of 2, and it goes up 1, 2, 3 over 1. 3 over 1, and then down 1, 2, 3 over 1. 3. That should be there. Okay, so we'll try to connect the dots. That's the original function. And let's actually do that in a solid line. So here's our original function, okay? It goes on both ways forever. This is our f at x, we'll call it. That one's easy to graph. We put in the vertical asymptote in for our reciprocal function of this. The y-intercept, we know as a rule, the y-intercept is going to be the reciprocal of the original y-intercept. So the original y-intercept was 2 over 1, you would say, right? So for our reciprocal function, 1 over f at x, what will our y-intercept be?
1 over 2.
Yeah, it's going to be 1 over 2. So in other words, about a half. So we're going to have it at a point there, okay? Now let's talk about some intervals here. Because this is at negative 2 over 3, nothing exists. Our only intervals are to the left of it and to the right of it, okay? So let's think about this function here. This function itself, okay, has to be have either positive or negative values. So if we start at this reciprocal and we go to the right, which way was our original graph going? In a positive or negative direction?
A positive.
Positive direction, which means this part of the reciprocal function is going to be positive. Okay, that makes sense too with what our y-intercept was. Our y-intercept was above the x-axis. Therefore, in order for the reciprocal function to touch it, it pretty much has to be above the x-axis, okay? Which then means if we're here, because this was linear, from our vertical asymptote to the left, so if we are starting here and going left, which way was our graph going? Negative. So because it was going negative, our reciprocal function is negative to the left of this, okay? So you would write that out something like this. You would say from negative infinity and negative 3 over 2. Okay. In calculus, we used to call it as x approaches negative infinity. That's what we would say, but you guys call it intervals here. So from the interval of negative 3 over 2 to negative infinity, we have a negative reciprocal. And from negative 3 over 2 to positive infinity, or in that interval for you guys, as we would call it as we approach infinity, we have a positive. Okay.
I think it's 2 over 3.
Oh, yeah, you're right. It is 2 over 3. I got it upside down. Good. It's 2 over 3. Good. Okay. That being our interval point. So we got quite a bit of information here. We know our reciprocal functions are not going to touch the x-axis because we also have a horizontal asymptote right along the x-axis. So we have one horizontal and one vertical asymptote because this is linear. We have our y-intercept. We know it's the reciprocal function. And the other major point we can really find out is when our reciprocal function will cross our original function. Okay, so I'm going to zoom in for that one. One way we can figure that out, right, is if we take the two functions. and set them equal to each other. We can find, what was it, 3x plus 2? I think so. As the original function, this was our f at x. When f at x is equal to 1 over f at x. In other words, when 3x plus 2 is equal to 1 over 3x plus 2. Okay? Well, in this case, we're trying to isolate x. So let's bring the bottom over and get rid of our fraction. So we'll end up multiplying the bottom of this times the original, right? That will give us a FOIL question. 3x times 3x is 9x squared. 3x times 2 is positive 6x. 2 times 3x is positive 6x, and 2 times 2 is positive 4. In order to solve, this is now a quadratic, and we're going to simplify it. 9x plus 12x plus 4, okay, is equal to 1. In order to solve it, we have to set it equal to 0. So we bring the 1 over, we get 9x squared plus 12x. It becomes subtract 1, so plus 3. I can factor out 3 as a common factor. So this would become 3. We get 3x squared plus 4x plus 1. Okay. Now, I can either factor or use the quadratic formula to find out what those 2 points are going to be. Okay, so this is finding out what the x values are when what two x values do these guys cross each other at. Okay, well, if I factor, I get 3 and 1 and 1 and 1. That should work. 3 and 1 and 1 and 1. I can't remember if you've done factoring this way.
You taught me last time, but I don't remember. I'm not that good at this.
Okay.
I do the AC value.
Okay, so you do 3 times 1.
Yeah. 3.
So what multiplies to 3 and adds to 4? Obviously, it's 3.
Yeah, 3.
Yeah, 3 and 1, right? So we know we're going to go across. We're going to get 3 and 1. That will give us our 4. Great. So our factored version of this will be 3x plus 1 and x plus 1. Right? And is equal to, you could say, y in this case, or 0. If you set it equal to 0, we'll just kind of scoot up here. That will give us 3x plus 1 equals 0, and x plus 1 equals 0. So in this case, x is a third, sorry, negative a third, and here x is negative 1. So let's go up to our graph. What it's saying then is that negative 1, when x is negative 1, oops, sorry, here, we're going to cross each other, our reciprocal function. So this being the linear point, it's going to cross here. That's purple. And what was the other one?
Negative 1 over 3.
Negative 1 over 3. So negative a third, somewhere like here. Okay. So they're going to cross each other here. Okay. When we go to essentially draw the function, we essentially have a function that gets very close to this vertical asymptote. So because we knew it was negative at this, sorry, positive at this point, it comes down. It's going to cross that purple and red and then come back out. See, mine's going up and down. It's kind of hard to do on this tablet. Oh, geez. Let's fix that. It's supposed to get ever and ever closer to our horizontal asymptote, but without ever touching it. Okay? So that's this part of the reciprocal function. And then this part here, we know we're going to cross there. So we know it comes over and eventually turns, comes down. Yeah, it's not supposed to go farther away. But that's the idea of the reciprocal function. We found our major points where they cross each other, which is negative a third and negative 1. The y-intercepts we discovered. We drew the originals, showed where they graphed, and we figured out where they were positive and negative. It doesn't, it's a gradual turn. It's not like a 90-degree angle. It's always a circular type turn when we go to graph this stuff. Okay, so that's the graph of a linear reciprocal function.